All right, you guys, we're going to continue our discussion on graphing rational functions, and we have a new example here. So we're going to walk ourselves through the same steps that we did in the previous video, but we just have a different function this time. So we have r of x equals x squared over x squared plus x minus 12. All right, so the step one, just like last time, they want us to make sure that it's written as a single rational expression. They want us to completely factor the numerator and the denominator. All right, so I'm going to go ahead and do that. All right, in the bottom, we have a trinomial whose constant term is 12. So I need factors of 12 that are going to give me 1, which is the center term. That's going to be 3 and 4. I need a positive 1, so the 4 needs to be positive and the 3 needs to be negative. All right, so that's our function completely factored. So we would check A and we would type this into the blank. Okay. All right, let's look at the second part. All right, so they want to know what's the domain. So remember, when you're finding the domain of a rational function, the denominator cannot equal 0. So we need to find out what those values are. So I'm going to set our denominator equal to 0. I'm going to set each one of those factors equal to 0. And I'm going to solve for x. So I'm going to add 3 here. And I'm going to subtract 4. So that means I can plug in anything I want into this function as long as those values I'm plugging in is not 3 and negative 4. So in set builder notation, I'm going to write brace x such that x does not equal negative 4 and 3. Okay. So when you're choosing your answer choice, be careful because the signs in each one of these are different. Like that's a less than, not equal to, greater than or equal to. So make sure you're choosing the right one. So I would choose B, and I would put in the values that I found. So negative 4 and 3. Okay. All right. The next part of our problem wants us to put our function into lowest terms. Okay. Remember, lowest terms means that you have no common factors that appear in both the numerator and the denominator. So we already got our problem into lowest terms here. Okay. And we don't have any common factors that appear in the top and the bottom. So we would say that it's already in lowest terms. Okay. All right, for the next part, they want us to locate the intercepts, okay? Remember, you have two types of intercepts. You have X intercepts and you have Y intercepts, okay? So I'm going to find the X intercepts first. Remember, to find X intercepts, you set Y equal to 0. All right, so with my function in its factor form, which we just found, I'm going to say 0 equals X squared over X minus 3. X plus 4. All right, I'm going to solve for x. So I can turn this into a proportion if I put 0 over 1. So I'm going to go from left to right. 0 times the denominator is 0 equals 1 times x squared, which is x squared. I'm going to solve for x. So since that's raised to the second power, the way that I cancel it out is if I take the square root of both sides. So 0 equals x. So I have one x-intercept at 0, 0. Okay. I'm also going to find my y-intercepts. So remember, to find y-intercepts, you set x equal to 0. All right, so everywhere that there was a 0 in that function, everywhere there was an x in that function, I'm going to set it equal to 0. So 0 squared, 0 minus 3, 0 plus 4. All right, I'm going to simplify. So 0 squared is 0. In the denominator, I have 0 minus 3, which is negative 3, and 0 plus 4, which is 4. So that's 0 over negative 12. We know that anything divided by 0 divided by anything is 0. So I have one y-intercept at 0, 0. Okay. So as I go back to my answer choices, all right, my graph has an x-intercept and a y-intercept. So I'm going to choose A. Okay. And I have an x-intercept at 0, and I have a y-intercept at 0. Okay, cool. All right, let's move on to the next one. So it says determine the behavior of the graph at R at any of the X intercepts. And then they want us to select the right answer choice. All right, so when we look at our X intercepts, let's change the color. Okay, we got our X intercepts from here. Okay, so remember, if you're looking for the behavior at the zeros, remember you have two types of behavior. If the multiplicity, okay, is odd, remember that means your graph is going to cross at that X-intercept. If your multiplicity is even, remember that means that you're going to touch, okay? And both of these are referring to what you're going to do at the X-axis, okay? So when we look at 0, okay, 0 came from this factor when we set it equal to 0, okay? So the degree on that variable is 2, all right? So the multiplicity is 2, and 2 is even, okay? So that means our graph is going to touch the x-axis once it gets to that point. That's its behavior. It's going to touch. All right, so let's go back over to our answer choices. All right, so A says that the graph will cross the x-axis. Nope. B says the graph will cross the x-axis. Nope. C says the graph will touch, but not cross the x-axis at x equals. That's what we want. It touches. And we need to put in our x-intercept there, which was when x equals 0. Okay, so our answer is C. Okay. All right, let's move along. All right, the next part of our question wants us to determine the vertical asymptotes, if any exist. All right, so let's do that. All right, remember to find vertical asymptotes. You set the denominator equal to 0. And you're going to solve. All right, so our denominator, let's go back up. Our denominator was x minus 3, x plus 4. I'm going to set each one of those factors equal to 0. I'm going to solve for x. All right, so I have two vertical asymptotes, one at 3 and one at -4. So when I go to answer this question, let's see what my answer choices are. The function has one vertical asymptote. Nope. The function has two vertical asymptotes. Yep, that's where I am. I have 2. And the leftmost, well, remember leftmost means smallest. And rightmost means largest, if you want to think about it like that. So my smallest one is -4. And my largest one is x equals 3. Okay, and I wrote them in equation form because the directions tell me to type equations. So x equals, okay? All right, let's go to the next one. Determine the behavior of the graph on either side of any vertical asymptotes, okay? So remember, if you want to determine the behavior of vertical asymptotes, you need to look at the multiplicity at the asymptotes. Okay, if the multiplicity is odd on a vertical asymptote, okay, that means it's going to clash. Remember what that means. They approach different infinities. And if the multiplicity is even, it means it's going to clap, which means that they're going to approach the same infinity. So when I look at these asymptotes that I just found, their degrees are both 1, okay? So their multiplicity is 1. 1 is odd. And since it's odd, that means that my function is going to clash when it approaches both of those asymptotes, okay? Which means that they're going to approach different infinities. Okay, so as I go over to my answer choices, A says it approaches infinity on one side of the asymptotes and negative infinity on the other, and then it approaches positive infinity or negative infinity on both sides. So in the first choice, it's telling you that you have asymptotes that clash and clap. We don't have that. B says it approaches infinity or negative infinity on both sides. All right, we don't have that. That's telling us that they're both going to clap. And C says it approaches infinity on one side of the asymptote and negative infinity on the other. That's what I want. That tells me that it's clashing. And it's clashing at both of my asymptotes. And I'm going to type them in there from smallest to greatest. So -4, 3. So C is my answer. All right, next one. So it says determine the horizontal asymptote or asymptotes if one exists. Okay, change our color. All right, so if we're looking for horizontal asymptotes, remember you have those two cases. Either the degrees are the same or the larger degree is in the denominator. So when we look at our function, all right, so let me write it again. So we had r of x equals x squared over x squared plus x minus 12. All right, so we're looking at the degrees. So the degree in the numerator, all right, is 2. The degree in the denominator is also 2. So since the degrees are the same, that lets me know that I'm going to have a horizontal asymptote, all right? And since the degrees are the same, my asymptote is going to be at the ratio of the leading coefficients. So the coefficient in the numerator is 1, even though you don't see it, it's understood. And the leading coefficient in the denominator is also 1. So if we say 1 divided by 1, that equals 1. So I have a horizontal asymptote when y equals 1. Okay, so I have one horizontal asymptote and it's at y equals 1. Okay, all right. The next one says determine if your function has any oblique asymptotes. Okay, well, we know if our function has a horizontal asymptote, it's not going to have an oblique asymptote. It's not going to have both. So it has no oblique asymptote because we already found that it has a horizontal. Okay, so we have no oblique. Okay. Then it says determine the points, if any, for which the graph of R intersects the horizontal and oblique asymptote. So if we want to solve for that, that means we're going to take our function and we need to set it equal to our horizontal asymptote to see if we get a true statement or we can solve for values. So my function was x squared over x minus 3, x plus 4. I think I got those signs right. Let's check. -3 plus 4, yep. All right, and we're going to set it equal to our horizontal asymptote, which we just found here was y equals 1. So I'm going to set it equal to 1. Now I'm going to solve this equation. So I'm going to make it a proportion. So I'm going to put it over 1, cross multiply. So that's going to give me x squared equals x minus 3, x plus 4. All right, this equation is quadratic now. So I need to multiply everything out and put it in standard form in order to solve. So I'm going to FOIL the right-hand side. Okay, so that's going to give me x squared equals x squared plus 4x minus 3x minus 12. I'm going to put in standard form, so I'm going to move this x squared. 0 equals x minus 12. And I'm going to solve for x, so I'm going to move the 12 to the left. So 12 equals x. So yes, my function is going to intersect my horizontal asymptote when x equals 12. Okay, so yes, r of x will intersect the horizontal asymptote when x equals 12. So let's see what the direction said. Type an ordered pair. Okay, so they want to actually know the point where it crosses. So we know what that is. So x is going to be 12 at the y value. Well, the y value that we plugged in was 1. That's where our horizontal asymptote is. So our graph is going to intersect at 12, 1. Okay, so we can come over here. Let's see what our answer choices are. The graph of R intersects the horizontal or oblique asymptote at, yep, that's what we're doing, A. And they want us to put in an ordered pair, so 12, 1. Okay. All right, the next part says use the real zeros of the numerator and the denominator to divide the x-axis into intervals. Okay, so we need to figure out where our graph is going to be below and above the x-axis. So let's change colors. All right, so when we're determining intervals, where our graph is above and below the x-axis. Remember, you're going to use the points that would divide the x-axis, which were going to be your x-intercepts, your vertical asymptotes, and if you have any holes. Okay, so if I draw a number line, okay, so I had x-intercepts. My x-intercepts were 0. And I had 2 vertical asymptotes. They were at 3 and -4. And I don't have any holes. So I need to split up my x-axis that way. So I have 3 points. And I need to put them in the order they would naturally occur. So -4 is the smallest, then 0, then 3. Okay. All right. Now I need to choose intervals. Okay. So these intervals, this would be from -infinity to -4. -4 to 0, 0 to 3, and 3 to positive infinity. Okay, so to determine whether or not you're above or below the x-axis, you need to choose test points. Remember, it doesn't matter what you choose for your test points. You just need to make sure you choose something that actually falls in that interval. So here I'm going to choose -5. I'm going to choose -1, 1, and 4 will work. Okay, so remember, you're going to plug these into your function to see if you get a positive value or a negative value. So if you guys forgot, our function is r of x equals x squared, x minus 3, x plus 4. All right, so let's plug them in. So this would be -5 squared over -5 minus 3, -5 plus 4. Okay, so essentially, I really don't care what the numbers are, to be honest. I just care if they're positive or negative. Okay, so in this numerator, we have -5 squared. Anytime you square a negative number, that's positive. In the denominator, we have -5 minus 3. That's going to give me a negative number. And -5 plus 4, that's also going to give me a negative. So we're going to have a positive number over a negative times a negative, which is positive. And a positive over a positive gives me a positive number. Which tells me, since I'm positive, I'm going to be above the x-axis. Okay. I'm going to do the same thing with the second one. All right, so it's going to give me a positive, negative, positive, positive over a negative, which is negative. So I'm going to be below the x-axis. Try the second one. All right, that's positive. It's negative. It's positive. Positive over a negative, that's negative. So we're below. All right, then we have 4 squared, 4 minus 3, 4 plus 4. That gives me a positive, positive times a positive. It's positive, which means I'm above the x-axis. All right, so now that I have all my intervals, I can answer their question. So let's see what they wanted to know. All right, so they want to know where we're above and below. Okay, so let's see if I remember. All right, so we are above the x-axis on these 2 n intervals. So negative infinity to negative 4 and 3 to positive infinity. So we are above from negative infinity to negative 4 and 3 to positive infinity. And we are below the x-axis at those two middle intervals. So those were, oops, I'm moving around a lot, sorry. Negative 4 to 0 and 0 to 3. All right, negative 4 to 0 and 0 to 3. All right, so A would be our answer. All right, now for the last one, they want us to choose the right picture. All right, so let's see if we can do this. So we already know that we're going to have two vertical asymptotes, remember? So B and A are already out, okay? And now from our intervals, we said that our graph should be above the x-axis between negative infinity and negative 4 and 3 to positive infinity. So let's see. So we should be above. So we're above from negative infinity to negative 4. So that's right. Are we above on this graph? Yes, we are. All right. And we should be above from 3 to positive infinity. So 3 to positive infinity, yes. 3 to positive infinity. All right. So far the graphs match. But we also have to be below the x-axis on these two intervals that we found below. Okay. So this graph, in between these two asymptotes, I should be below. Do you see how I fall beneath the x-axis here? This one, the interval splits. So you're negative on the first part, but you're positive on the second part. So D, we can throw out. D is not our answer either. So our answer for the correct picture is C. All right. I hope this helps.